Hello and welcome. My name is Western Onzere, and this is Minic Analytics, where we show you how to build, deploy, and monitor your machine learning and AI systems in production. In today's topic, I'm going to show you how to perform the extraction, transformation, and loading process. So that is the ETL process for this project that we are going to be doing. So this will be a Churn classification project. And the first step that we are going to be handling is the ETL process. So in this video, I'll show you how to create a data lake where we will be storing our raw and processed data. Then after that, we will do the extraction, transformation, and the loading process, and we will load our data into a data warehouse where we can now query that data when developing our model. So basically, that's what we are going to be discussing in this video. So subscribe to the channel if you haven't, and let's get started. So we are going to start by me showing you the flowchart of what we are going to be doing in this video. So this is the flowchart that basically sums up what we are going to be discussing in this video. So as I had alluded earlier, is that in a machine learning production system, or in production systems where you are building and developing these machine learning systems, possibly you might be getting data from different sources. So that is what I have represented under this section. So basically, we are getting data from different sources: data source 1, data source 2, data source 3, and several other. So we build different pipelines like this one, these pipelines. So we build these pipelines, and after that, we store that data in a data lake. So data lake here represents a database that we are going to be using to store these raw and processed data. Since this data is unprocessed, then we need to transform this data in such a way that we are going to be using while developing our machine learning systems. In this case, the churn prediction system. So we create another pipeline, which is the ETL. So something like the extraction, transformation, and loading. So this will be the ETL process. So this pipeline here. So this pipeline represents our ETL process. So the extraction, transformation, and loading process. So we extract data from our data lake. Then after that, we transform our data. So transformation of our data entails things like removing the duplicates, checking if you have missing values. With the missing values, you can impute the missing values, checking the range of the values, checking if you have the correct categorical columns, if you have the necessary categorical values in those categorical columns, and so much more. So all that will be contained in the data transformation. This transformation, I think, is data dependent because different data have require different types of preprocessing steps. So the transformation process is all about us preprocessing this data, ensure that our data is consistent and clean so that we can build a machine learning model on top of that. So after we have completed transforming our data, the next step is about loading. So we are going to load our data. Let me try to use a different. So after that, we are going to load our data. Then we are going to load our data into a data warehouse. So this data warehouse is where now we store our clean data that has been processed and is now consistent or is at par with what we necessarily want with our data. So that data will be stored in a data warehouse. So you can see the stark difference between a data lake and a data warehouse. So data lake stores unprocessed data, while data warehouse stores the clean processed data. So data in a warehouse can be used for several things. For example, you can use it for visualization, checking about your data. You can also use it for a machine learning, developing a machine learning system. So for our case, this is a churn prediction model. So we'll be using our data for a machine, developing a machine learning model. You can also use your data for a business intelligence and so much more. So essentially, this is what we are going to be doing in this video. So we are going to perform this process, the extraction, transformation, and loading process. So we are not going to develop these pipelines because I do think that is beyond the scope of this video. So I'll just show you how to create a data lake. Then I'll show you how to do this extraction, transformation, and loading process. Then we can store our data in a warehouse. Then in the next video, then we can start now developing our machine learning model. Okay? So let's now jump into our Jupyter notebook where I want to show you how we now build the ETL process, the extraction, transformation, and the loading process. So before we get started on that, I will be using a MongoDB database. So since I am using a free tier, then I won't be able to create a data lake or a data lake pipeline. But for instead of that, I will just create a new database. And that database, instead of it resembling a data lake, we'll just use it in the place of a data lake. Okay, so I've just created a new database, and I've created a new database called Churn. So Churn is our database, and it contains data, web churn data. So let us assume that we have already collected data from different sources, and we are now storing our data into this database Churn under collection name web churn. So this web churn now contains the raw and processed data. So we are going to query this database, specifically this collection. Then from here, we are going to perform the extraction. We are going to extract from this database. So we are going to extract from this database. And after we are done with that, we are going to perform a transformation of this data so that we can remove if you have duplicates, you can remove that, check if our data has the correct data types and all that, our schema and all that. So that will be under the transformation. And after that, we are going to now load this into a new collection. So I just create another collection under here, and I will call it transformed web churn, something like that, and that will now represent our data warehouse. Okay, so you can also do the same. So if you have if you can just create a free account with the MongoDB, then under database, so after you create your cluster, you can come to the database. You can say browse collection. So when you click at browse collection, you'll be directed to this page. Then just create a database. When you click, you give a database name and then a collection name. Then you can just make add additional preference according to your needs. Okay, then if you follow those steps, then you will have created a MongoDB or just created a database that you can use. Okay, so we have already created our. So let's assume that this churn represents our. The churn represents our. Let me see if we can go back. So let's assume that the web churn represents our data lake. So let's say this is the web churn. So let's say the web churn represents our data lake. This is the web churn. So we are going to query. We are going to extract data, transform, and then load. So let's go to the Let's go and now start the ETL process. So as usual, we are going to start by importing the necessary libraries. So I'm going to import the libraries that we will be using in this analysis. So let me execute this. So these are the libraries: pandas, numpy. For this case, I don't think we do need the visualization libraries. Okay. So pandas numpy for imputation, we'll use the iterative imputer and the k nearest neighbor imputer, I think, for the categorical values. Then standard scalar, Mongo client, and date type. So let's start now with the extraction process. So let's start with the extraction. So we are going to extract our data. So let's start with the extraction process. So I'm just going to use one cell for this. So the first thing is about importing the data. So first thing we need to do is importing our data. So let's say imports. We are going to import our data. We're going to import our data. So I'll just create a function for that. So def extract data. So we are going to extract our data from that specific MongoDB. So when extracting our data, let me use this. So I'll just put some comments. This one will be reading data from a specified file path. So let's say data from MongoDB, let's say MongoDB. So let's call this, let's name this as our data lake. Okay. So from this, we are going to read that data. So the first thing that we need to do is to establish a connection to MongoDB cluster using the provided URI. So we are going to establish connection with this database. So to establish that connection, I'll just go to overview, or you can just click the database. Then from here, you need to click the button connect, because we want to connect with that specific database. So you can use, so there are different ways you can use. You can either use the different drivers. For example, this one here. But for my case, I'm going to use. We'll be using the compass to connect that. So I'll just copy this link here, this URI. So I'll just copy this, then go back to my Jupyter notebook. Then from here, you can then create a client. This will be the Mongo client. Then inside the brackets, you pass in that link. The password, make sure you, while creating, I think when creating your cluster, you'll be required to create or generate a password for that. That was just a placeholder for your password. And I think this link remains the same. So after you establish the connection, then the next step will be selecting so we select the Churn database. So for the Churn database, so I'll just create a new variable for that. Okay. DB. So I'll just make reference. So the client will be Churn. So that's it. So we are querying from that. So we are querying from our collections. We have a database, and our database is Churn. So this one here, we are calling this one Churn. Under Churn, we have the collection name is now the web Churn. So after this, we need to create select the web Churn collection within the Churn database. So that's the next step. Then select the web Churn from that. So then we can call it collection DB. We reference web Churn. That's it. Then after this, we need to use the pandas data frame to convert our collection into a data frame using the data frame function. Then after that, I think we need to drop one of the columns. So that column is the that column. Let me. Okay, that's okay. So that column, I think it's usually this alphanumeric, like this one, alphanumeric code that represents every example in your data. So we're just going to drop. We'll be dropping this first column. We don't need it, so we are using this to drop it. And after that, we return our data frame. So after this, so I'll just write the whole code, then we just execute it one time. So after the extraction process, the next step is all about the transformation. So we are going to do a lot of things under the transformation. So for the transformation process, I'll just copy whatever I have already done because it's quite intensive. Let me just copy. So for the transformation process, so this is the transformation, and I think okay, then and it's target column return df. So that's it. So I'm just going to take you through what I've been doing under the transformation process. In most cases, you'll find these processes being using the not the sklearn. I'm forgetting that. Anyway, so under the transformation, so this one will perform a data transformation on the input data frame. So after we have extracted that from our data lake, we are going to perform a series of data transformation steps. So the first thing is about converting the data into appropriate data types. So we want to map our numeric columns and ensure that those columns are the data type is numeric, while for the categorical columns we will be using the object. Okay, so for the numeric columns we are going to give a list of the columns in our data that are of type numeric. So then after that we use the numeric function to numeric function to ensure that these columns we are mapping them, ensuring that they are of a numeric data type, either float or integer. Also, we have columns such as the last visit time. So we want to make sure that these columns are of a date time, and we're using this as a format. So for example, this is for hour, minutes, and seconds. So we want to make sure that that column is of date time format. For the categorical columns in our data, again, we need to make sure that we have provided a list of those columns. And after that, we use as type object. So make sure that they are of object, a data type. And for the joining dates, this is another column. Also, I think this one is for dates, for the dates. So we need to make sure, again, we use the toDate time function to make sure that the values under this column are of date time format or date type. Okay. So after we are done with that, we need to impute for the missing values. And for the missing values, remember we do have categorical columns, and then we have the numeric columns. So for the categorical columns, we are going to start imputation process using the numeric columns. So we are going to do first with the numeric columns, then the next will be the categorical columns. So for the numeric columns, you're going to use the iterative imputer. So I'm going to show you how. The first thing is to create a list of the columns in the numeric columns, but we need to, when using the iterative imputer, we need to not include the target column. Then we create an instance of the standard scaler, then copy the data frame to create a new copy of the data frame so that we don't interfere with the data in our original data frame. Then after that, we fit and transform the data using the scalar that we created here. Then after that, we apply the iterative imputer so that we are able to, I think this uses the distance to try to impute the missing values. Then after that, we create the instance of the iterative imputer, then use the iterative imputer, so fit and transform on our DF scaled data, this one here. So after we are done with that, then we use the scaler to do the inverse transformation so that we go back into what was our original data, plus now this data does not contain missing values. Okay. So the next imputation process is on the categorical columns. So I did a research and found that you can use KNN imputer for categorical columns. So for the gender column, we are going to, if there is an unknown. So these are some of the things that I first looked into my data, and I found these issues with the data itself. So these are the preliminary things that I did with the data. So don't think that I'm just doing this off my head. So I just first had a look on my data. And from there, I was able to piece out and see which things I can just create the ETL process on my data. So these are the things. So my data contained missing values for some of the categorical columns. So for the gender, it contained the unknown. So for the unknown, I'm just going to replace that with a missing value, then include that as a list in the categorical columns variable for the list that we are going to use the k-nearest neighbor as an imputer. So we create an encoder, ordinal encoder, create an instance for that, then we fit that to our categorical columns in our data frame. So then after that, we fit, so we do the fitting, then we do the transformation process. Then we create an imputer for that with some hyperparameters, neighbors is equal to 5, the matrix non-Euclidean distance, weight distance. Then after that, for this, you can, if you want to gain some, okay. So after that, I think after creating the instance of the imputer, we again fit. Then we do the, after encoding this one here, after encoding, we fit, then we do the inverse transformation so that we go back into our original data. Then you can use this to print out the categorical columns and see which columns and see if your data is set at the moment. Okay, after imputing, after doing the k-nearest neighbor, after using the KNN imputer. So in terms of feature engineering, so for the date time, because I didn't want this to be infinite, so I just created an arbitrary date. So we are setting our last date to be 17th of May 2024, and we are going to calculate the tenure in months for each client or customer, so the number of months that they have been using our service. So this will be the tenure in months. For the visit hour, so we are going to sort the last visiting time. So if it is 5 p.m., 4 p.m., 3 p.m., and so on and so forth. Then we can also add another features, for example, the login spent ratio, which is just an average time spent divided by the average frequency of login days. So the time spent on the website or something like that. The login transaction ratio, again, this is just a ratio between the average login days, so the days that they have logged into the website, and the average transaction value that they have made. So we can calculate the transaction ratio between the days by dividing the days that they have visited the website and the transaction value that they have made during those days. So for the target column class distribution, again, for this case, I tried to work my way around. So I just wanted to have three classes. So class 0 to represent, so class -1, 1, and 2 in the original data. So I just going to convert those to 0, so that 0 represents customers who have already churned, Then value 1 will value 3 will represent the customers at risk of churning. Then 4 and 5 represent the customers that are active, that the business is engaging with them. Then after that, we are creating a dictionary, and then we map that using the mapping so that we create our final churn risk score using these. We'll have 3 classes, 0, 1, and 2. Also, I will be renaming some of these columns. So for example, the average frequency login days, we can just rename that to frequency. Average transaction value, for example, average, this one, instead of the average transaction value, you can just call that column monetary to show the monetary value for each customer. Then the recency days since last login, you can just convert that to a recency. Then we use the mapping and then rename these columns. Then after that, the last instance is about us now loading this data. So we load our data. So after doing the transformation process, we need to load our data. So where are we loading our data to? So we are loading our data. If I may go back, so let me use this pen. So you have seen how we handled this segment, the extraction, the transformation. Now we are at the loading phase. So we are loading our data into a data warehouse. So when loading our data into our data warehouse, remember we are going to create another collection just under the churn column, under the churn database. That collection will now represent our data warehouse. Okay? So saves the transformed data frame to a new MongoDB collection. So we are creating a new that. Then now we again create establish a connection to the MongoDB cluster using the URI provided. So this one here. Then we specify the database. So we are not getting a new database really. So we're just getting that using the same database churn, but the collection name now changes. So instead of web churn, we are now using a new collection name, transformed web churn. Now this represents the data warehouse where we are storing the preprocessed, the transformed data. So we are using a new collection name for that. So when we build our model, this is the collection name that we will be querying so that we are able to import data into our model. Okay. Then we need to perform some steps. For example, convert the data frame to dictionary and insert into the MongoDB. So remember earlier on, after we were saving data into the data frame DF, we first converted that into a pandas data frame. So we need to do the inverse of that. So we are going to be doing the inverse of that. So convert the data frame to a dictionary, this one here, where we have the key and the value pair. So if you look at them, for example, this one, for the data in our MongoDB, you can see it's being saved as a key and the value itself. So key and value pair, so in form of a dictionary. So we need to do that before we send that data into that collection. So we convert that to a dictionary, then insert many, because we are inserting many of these examples or records. So after that, then we can print a statement, data saved to MongoDB collection, transformed web churn. So we need to close this with the main block. So again, I'll just if underscore name, so the main block. So let me add this. This is the main block. Okay, so that's it. With the so this is all about now with the extraction, transformation, and loading of the data. So this is the process that we can use. So in many ways, this process is usually created as a pipeline, but I've just tried to at least show you. So you can just convert this into a pipeline that will be handling your data. So when doing, let's say, something like using the Apache Kafka. You can link this with the Apache Kafka and all that. Try and recreate this. So assuming these are your pipelines, so you can use the Apache Kafka, the Apache Kafka, and all the other tools to try to convert these pipelines now as they merge into a data lake. So maybe in other videos, other series of videos, we might, but that is more of a data engineering element, but not machine learning. But we might find ways to include that in one of our videos in future. Okay, so I'm just going to execute this cell to ensure that our data is ensure that we load our data. So after loading our data into the Mongo into the new collection, we can then visualize our data. So you can I found another thing with the MongoDB Compass. You can use it for different things. For example, when you want to load data into your collection, then one of the tools that you can use is the MongoDB Compass. So with the Compass, it's very easy. So you can just download the Mongo Compass, MongoDB Compass. So let me connect. So with the Compass, so at the Compass, you can then I don't have MongoDB Compass installed, so you can just download this. So this is a graphical user interface where you can visualize your data from an interface. You can visualize your data and maybe add other functionalities. For example, if you want to add data into your database, if you want to export data into a database, and all those information. And also you can able to visualize the other database that you do have in your MongoDB. Okay, so for our case now, we're just dealing with the Churn data. Okay, so for example, if you have another projects, for example, the lead generation project and all that. Okay, let's see if that process is complete. So, data saved to a MongoDB collection, transformed web Churn. Okay, so after this process has completed, you can see now that we have now saved our data to MongoDB collection, transformed web Churn. So I think now the process is complete. We can now access our data into that in that folder, that collection. So browse collections. Then we can see, go to our Churn, and you can see now we have the Churn. We have the Churn transformed web Churn data. So this is data that is transformed. Okay, so we can now see we have our data here. Try to increase the font. So this is the data itself. So if you want to visualize this data, you can use the MongoDB Compass. So you can just refresh because we have some addition. Then when we refresh, then in the Churn, we should be seeing some, should be having a new data in the Churn. Should be having a new data in the Churn. In the Churn. Let's see. Let's try to exit, then come back. We can just copy the string, just copy this. This is what is needed. Then copy it here. Then we can save and connect. Just connect. So we are using the MongoDB Compass. So under Churn, you can see now we have the transformed data, and this is our data. So this is the transformed data after applying the extraction, transformation, and the loading process. After using that pipeline, we are able to reach to this place where we have now loaded our data into a data warehouse. And from there, we can now start querying our data and develop this churn classification model. So that's it. That's it for this tutorial. So I just wanted to show you how we can extract data, transform data, and store data into our warehouse. And then from the warehouse, then we can query that data in that database for us to start building our model. So this is the first video of this churn prediction model. So we will be building a churn prediction model that will enable us to predict the churn status of different client customers who are using a website for specific products and services. So that will be our project. Again, it will be an end-to-end project. So I've tried to include other things, other tools into this project. So this will be the first one. The second one will now start the development process. We create the next step will be about creating a Git repository and project setup, project files, and all that. So that will be the next video after this. So that's it. That's it for today. Once again, thank you for your time. And if you haven't subscribed to the channel, please before we end this, consider subscribing to the channel and like the video on your way out. And see you in the next one. Bye.